Welcome to the first class of our course on Programmable Logic Controllers, PLCs. Today, we'll dive into the fundamentals of PLCs, including their definition, structure, and the various types of inputs and outputs they use. So let's get started. What is a PLC? PLCs are industrial computers used to automate and control industrial processes. They are designed to withstand harsh industrial environments and can be programmed to perform a wide range of tasks. Structure of a PLC. PLCs typically consist of a central processing unit, CPU, input-output, I/O modules, and a programming device. The CPU processes the program instructions, while the I/O modules allow the PLC to communicate with the outside world. Digital and analog inputs and outputs. PLCs can accept both digital and analog inputs and generate corresponding outputs. Digital inputs and outputs represent discrete states, such as on-off or true-false, while analog inputs and outputs represent continuous values, such as temperature or pressure.
Programmable logic controllers, PLC, are industrial equipment that controls the operation of automated machines and systems. According to the IEC 61131/2003 standard, the programmable controller is a digital electronic system, developed for an industrial environment and which uses a programmable memory for internal storage of user instructions, to implement specific functions, such as logic, sequencing, timing, counting and arithmetic, in order to control, through inputs and outputs, different types of machines and processes.
It's notable how the standard emphasizes the industrial environment for which these controllers are designed. PLCs must be able to operate reliably in challenging conditions, such as high temperatures, vibration, and electrical noise. The mention of programmable memory is interesting, as it speaks to the versatility of PLCs and their ability to be programmed and reprogrammed to suit different applications. This is a key feature that distinguishes PLCs from hardwired control systems. The list of specific functions, such as logic, sequencing, timing, counting, and arithmetic, gives a sense of the breadth of capabilities that PLCs can offer in controlling and automating industrial systems.
Structure. A PLC usually consists of
power supply. Provides power to the PLC system and ensures a stable and reliable source of electricity. CPU. The central processing unit of the PLC, responsible for executing the control program and communicating with the other components. Digital input module. Captures the status of digital inputs, such as switches and sensors, and sends this information to the CPU. Digital output module. Sends control signals to actuators and other devices based on the control program. Analog input module. Captures the value of analog inputs such as temperature or pressure sensors and sends this information to the CPU. Analog output module. Sends analog control signals to devices such as valves or motors. Network modules. Enable communication with other PLCs or devices over a network. Special modules. Provide additional functionality such as high-speed counting or specialized communication protocols. Yes, the modular design is a key feature of many PLC systems. This means that the system can be configured with a specific set of modules to suit the requirements of a particular application. For example, a system that only needs digital inputs and outputs can be configured with just the necessary modules, while a more complex system may require a mix of digital and analog I/O, as well as special modules for communication or high-speed counting. The modular design also allows for flexibility and expansion. If the requirements of a system change over time, additional modules can be added or existing ones replaced as needed. This can make PLC systems a cost-effective and scalable solution for industrial automation. Additionally, the modular design can also make PLC systems easier to maintain and troubleshoot, as individual modules can be replaced or serviced without affecting the rest of the system. Monoblock PLCs. Yes, these are PLC systems where the CPU and I/O modules are integrated into a single unit, as opposed to the modular design we just discussed. Monoblock PLCs can be more compact and may be a more cost-effective option for simpler applications. They can also be easier to install and set up, as there are fewer components to connect and configure. However, monoblock PLCs may have less flexibility and expandability compared to modular systems. as the number and type of I/O modules are fixed. Overall, the choice between modular and monoblock PLCs will depend on the specific requirements of the application and factors such as cost, space constraints, and the need for future expansion or modification. Yes, PLCs with Integrated Human-Machine Interfaces, HMI, are becoming increasingly popular in industrial automation. This integration can provide several benefits such as reduced complexity and cost. Integrating the HMI into the PLC reduces the number of components needed in the system, simplifying installation and potentially reducing costs. Improved communication. With the HMI and PLC in the same unit, there is less potential for communication issues or delays between the two components. Increased functionality. Some integrated PLC HMI systems offer advanced features such as data logging, alarm management, and remote access, which can improve the overall efficiency and effectiveness of the system. Improved user experience. The integration of the HMI into the PLC can provide a more intuitive and streamlined user interface, which can make it easier for operators to use and maintain the system. Thank you for joining me for this first lesson in our PLC course. In the next lesson, we'll dive deeper into the world of digital and analog inputs and outputs, exploring the different types of modules and how they're used in PLC systems. This is an important aspect of PLC programming, so make sure to join me for the next lesson to continue your journey toward becoming a PLC expert. And before I go, I'd like to thank you for watching this lesson and for your enthusiasm for learning about PLCs. Your interest and engagement are truly appreciated. Additionally, I'd like to remind you that Professor Roberto Araújo is currently reviewing all the course content to ensure that it's up to date and provides the best possible learning experience. Until next time.